Today we're going to take a look at how to graph graphs of tangent, cotangent, secant, and cosecant functions. And we're going to start with the graph of tangent, and we're going to graph these very much in the same way that we were dealing with when we looked at graphs of sine and cosine. We're going to start by taking a look at the unit circle that we have. And when we remember our unit circle, what I want us to sort of focus on or think about is some different angles this particular time. And so instead of looking at the angles where we had what were we working with? The quadrantal angles we were working with. Today we're going to take a look at some different ones. So the angles we're going to look at instead are going to be at negative pi halves, at negative pi fourths, 0, pi halves, and pi fourths. And what I want you to remember is the ordered pairs that are associated with those particular points. So down here at the bottom we have, of course, 0, negative 1. Over here at negative pi fourths we have negative square root 2 over 2 and square root 2 over 2. Those are terrible 2's, I'm sorry about that. Over here at this quadrantal angle at 0 we have 1, 0. Let's try these square root 2's again. Up here at pi halves I have square root 2, a little bit better, over 2, and then square root 2 over 2. And up at pi halves I have 0 and 1. And what you want to remember is that tangent is actually, so this is the graph we're going to be looking at, is that y equals tangent of x, is that the tangent value is the y coordinate divided by the x coordinate at these particular angles, which is what we're going to be looking at. So let's take a look at creating that same kind of a t-chart or whatever with x and y. And our x values are these angles. So we have the angle 0, oops, let me not start at 0, negative pi halves, negative pi fourths, 0, pi fourths, and pi halves. So at negative pi halves, if we actually look at the y value divided by the x value, we would get negative 1 over 0, and that's undefined. So I'm just going to write UND for undefined here. And what that's going to translate into on our graph is actually an asymptote, just like when you did rational functions in an algebra course back when. Now at negative pi fourths, we notice that we have the same x and y value except one of them is negative, so when we divide them, it doesn't really even matter the order we divide them, we're going to get negative 1. At angle of 0, over here at 1, 0, we have the y coordinate divided by the x coordinate, and we get 0. At pi fourths, we have square root 2 over 2, square root 2 over 2, so they're the exact same x and y coordinates, so we get the value of 1. And then at pi halves, I have the value 0, 1, and so if I divide 1 by 0, of course, that is also undefined. So on my xy axis over here, I'm going to start and I'm going to have to create some asymptotes, and just to make them clear that they are asymptotes, let me use, I'll use yellow, and we will use a dotted line down here. Sorry, the iPad likes to connect my dotted line to make it a full line, but it should be dotted. And then that's at negative pi halves, and then we need one over here at pi halves. And in between, we're supposed to have a point 0, 0. At negative pi fourths, it should be negative 1. So here we are right there. And so let me label these. This was negative pi halves, negative pi fourths. I'm going to be over here at pi fourths. This is negative 1, and we're going to be up here at positive 1. And the other one then is at pi fourths, we're at 1. And so we're going to connect these as best we can in a nice smooth way. It looks something like this. Of course, most of the time you're going to be asked to do 2 rotations or 2 cycles or 2 periods of this function. And if you notice, of course, this is only 1 because I've only got 1 image here. So we can repeat the image to the left-hand side sorry, to the right-hand side. Get the sides right of where I'm going. And we can do this by kind of repeating where we are. So I didn't mark the last asymptote. It was at pi halves. So if you think about your unit circle, where will the next asymptote be? That is to say, where will the next time, if I'm going around the circle counterclockwise, where will I next get my y value to be 1 or -1 and my x value to be 0? Well, we had that happen at the bottom of my circle down here and at the top of my circle. So if I keep going around, I'm at the top of my circle, and then I keep moving to the right-hand side, curving around my unit circle, and then back when I get to the bottom, which is at 3 pi halves, would be the next location that I would have a x value of 0, giving me an undefined asymptote, or an undefined y tangent value, which gives me an asymptote. And then halfway between, of course, was where I got 0, and of course on my unit circle, that is back over here at pi. So there I am at pi, and the image is the same, so I'm going to repeat the image like so. And this would be my graph of tangent. Of course, the image keeps repeating and repeating. Now, just like in the last section, we want to take a look at some of the properties that we have. So some of the properties that we end up having on the first one is that my domain and my range. Well, my domain's not all real numbers any longer. Yeah, I've got some locations that I cannot have values for my input, and if you take a look specifically back at this graph, it looks like they're occurring at all the pi half values, and we saw that happen earlier in the section when we did sine and cosine. So we would say this is all real numbers except, and it would be in pi halves, where n is odd, right? And then my range is actually really nice on this one. My range is actually all real numbers, or you can write -infinity to infinity if you'd like that one. Because if you take a look again at the graph, we can go from all the way down. The y values can go as far down as we want, and can go following your graph as far as you want. It's nice and smooth. There's no jumps or places that are gaps of my my y values, my y-axis. So this is 1 and 2. My third one is the fact that this is an odd function. It has origin symmetry. And if you take a look again, if you took this graph, just look at the one in the middle is the easiest one to take a picture of, and sort of take it and spin it 180 degrees, and it will land right back down on top of itself. The fourth thing is, of course, that this is periodic. And it has a period, in this case, of pi. Not 2 pi, but of pi. So my period's actually pi for tangent. It goes from -pi/2 to pi/2. That full length is pi. The fifth issue is the x-intercepts. We have x-intercepts on this graph. They actually are occurring at every pi value. So they occur at n pi, where n is an integer. So at all of the pi values we have that, right? There's a 0 at pi, and we can infer that it's going to be at 2 pi and 3 pi and so forth, and it will work that way. My y-intercept, there's only one of them, of course, and that is at the origin at this one as well, 0, 0. I have asymptotes on this graph, so these are my vertical asymptotes, VA for vertical asymptotes. And those are also occurring at n pi over 2, where n is odd. All my half pi values. It's the same domain issues that I used on part 1. And the last thing that I want to make mention of is that this is an increasing graph, or you can say it has increasing branches. So we remember we read graphs from left to right, and so if you're looking at this graph, and you start on the left-hand side, you'd start down here at the arrow down here at the bottom, and you'd arrow up to the top, going upwards. And we would end up going from left to right, we would go up, so it's an increasing graph. So that's the graph of tangent. So let's do the same thing with cotangent. So with cotangent, again, we're going to start with my unit circle. Unlike tangent and secant, or not secant, but cosine and sine, I am going to use the top half of the circle on this one. So let's take a look at, we're going to use 0, we're going to use pi halves, we're going to use pi fourths and then pi halves, we're going to use 3 pi halves, I'm sorry, 3 pi fourths, excuse me, and then pi. And so we're going to use the top half of my unit circle to create my ordered pairs. So let's do first the ordered pairs that are here. So of course this is 1, 0, and then just like last time we had square root 2 over 2, square root 2 over 2. At the top I have 0, 1. On the left hand, kind of in the middle here, I've got negative square root 2 over 2 and square root 2 over 2. And then the last corner over here at pi, I have negative 1. There we go. So I'm going to create that, again this is the graph of y equals cotangent of x, and my cotangent value is found by taking the x coordinate divided by the y coordinate. So our first x value is at 0, that's our first angle. And then we have pi fourths, we have pi halves, we have 3 pi fourths, and we have pi. Now if I take my x coordinate, which is 1, and I divide by my y coordinate, which is 0 at the first location, I would actually get this to be undefined, just like on the last one. Now then at pi fourths, when I divide square root 2 over 2 by square root 2 over 2, of course I get the value of 1. Up at pi halves, when I divide 0 by 1, I get 0. At 3 pi over 4, if I divide negative square root 2 over 2 by square root 2 over 2, I end up getting a negative 1. And then at pi, if I try to divide negative 1 by 0, of course that is also undefined. So I'm going to create my graph. I'm going to actually start at the y-axis. And just like last time, I actually am going to do asymptotes at the values that say undefined. So I've got, let me finish this asymptote right here. I've got this asymptote at 0, and then I'm going to have an asymptote over here. And that works better, I think, that way. At pi, here's 0 and here's pi. Halfway between was the pi over 2. Halfway between that's pi fourths. And we have 3 pi fourths. Now my x-intercept was at pi halves, because it said that pi halves I'm at 0. And I have values of 1 and negative 1. At pi fourths I'm at 1. At 3 pi fourths I'm at negative 1. So my graph looks something like this. And the pattern will repeat as you would imagine, and it is truly the case. It will have the same asymptote situation over here at exactly pi halves more. Here's the graph. And so here's pi, 2 pi, exactly pi more. And then I've got halfway between, so this would be 3 pi halves. And the graph will cut right through there at the origin, or at the x-axis, and it will be a graph that will swoop down in the same pattern as before. Yep, looking something like this. Okay, so just like last time, we're going to look at some properties now. The first property, you should be getting the hang of this right now, is domain. So the domain, again, is all real numbers except some. And on this one, if you look back here, it's except pi, 2 pi, of course it would be 3 pi, 4 pi, so this is except n pi, where n is an integer. Secondly, the range, just like the range on tangent, the range here is in fact all real numbers, or we can write that as negative infinity to infinity. The third feature is that, again, this is an odd function. This one's a little bit more difficult to see because I didn't actually draw anything on the left-hand side of the graph. But if I go back to my graph and just sort of imagine what's over here, I have another graph, something like this over here. And if I took my graphs and I rotated them around, they would in fact land on top of themselves. So I do in fact have an odd function which another way we've said that is that that's origin symmetry. All right, and then I've got number 4. Number 4 is that it's periodic, right? It's periodic, and it has a period of pi, so it's periodic with period pi. My x-intercepts, well, my x-intercepts are actually occurring at the pi halves values. So my x-intercepts are at n pi halves, where n is odd. My y-intercept, well, my y-intercept, there isn't one. I've got an asymptote there on this particular one, so I don't have that going on. I do have vertical asymptotes. My vertical asymptotes are at n pi. That's the exact domain issue spots from part 1. And this is occurring for all n that are integers. And then the last issue that I want to make note of is that these branches are decreasing. Okay, so if you're drawing a graph of tangent, the graph's increasing branches. And then for cotangent, it has decreasing branches. Alright, so some guidelines for graphing, some reminders, and things to think about on how we actually accomplished this. So this is to graph the, if you have a graph that's got a tangent bx or a cotangent bx, the b value is positive. Again, if the b value is negative, you use even on properties. So for tangent and cotangent, that means the negative would actually come out in front of the graph because they're odd functions. The a part of this, the a right here, and right here, they don't really affect the general shape of the graph. Yeah, they stretch this graph out a little bit more, they kind of squish it back towards the x-axis, but they don't change the general shape of the graph, which is what we're getting at here. The b value changes the period. So to determine the period, it's pi over b, and then you locate 2 adjacent vertical asymptotes. So in reality, if you're asked to find the period, you'll find pi over b. But if you're actually asked to draw the graph, you can draw the graph by finding these asymptotes and finding these 2 adjacent asymptotes. And the way that you do that is, for tangent, you go from negative pi halves to pi halves. That was the standard period. And you put the bx in the middle, and that bx being in the middle will in fact have your asymptote, your period, let's say it that way. The period will then be determined by taking that b value and solving for x. And then for cotangent, it goes from 0 to pi. And then we sketch the asymptotes that we just found. We divide that interval in half, and that middle value is the x-intercept, unless you have a vertical shift going on. And then you use the x-intercepts, and you draw the asymptotes to sketch the appropriate curve. And you draw additional cycles if you need to. Alright, so let's try an example. Okay, so what we're going to do is this is a cotangent graph, so we need to go from 0 less than, we put the bx, which is 3x in this case, less than pi, and we solve this for x, which means we would divide by 3. So I've actually got from 0 to pi thirds is where I will have a full cycle or full period of my graph. So I can draw the graph. My graph will have asymptotes where I just now located them at 0. And then at pi thirds, and we'll label those 0 and pi thirds. We'll label the the halfway point, the midpoint of those two, which is pi over 6. Remember, all you have to do is to add 0 plus pi thirds and divide by 2. That's pi 6. And because this is a cotangent graph, it's decreasing. So it goes like this. Now, it wants me to have 2 periods, so I need an additional period. So there's going to be another one either on the right-hand side, if you prefer to draw it here, or on the left-hand side. Just because my graph is already set up to push it toward the right-hand side, that's what I'll do. And so if we wanted to find out where the next asymptote is, well, it took us from 0 to pi thirds to get to the first asymptote, so it'll take us to another pi thirds to get to the next asymptote, which would be 2 pi thirds. And then we need to know the halfway point, halfway between pi thirds and 2 pi thirds. So if we take 1/3 and 2/3, I get 3/3, right? Which is the same as number 1. And I divide that by 2, I'd actually have 0.5 or 1/2. So this is actually pi halves in the middle. It's kind of interesting, unexpected. And that would be my x-intercept. So I'll come down right through pi halves and I have my cotangent curve. And of course you could have put that same curve on the left and you would go on over to negative pi thirds, and negative pi 6 would be the halfway point, and so forth. Alright, let's do one with tangent now. Alright, so that 1/2 in the front, I wanted to do one to show you for real that that 1/2 does not affect anything else going on. Now, that is the general shape that I'm trying to draw, it won't affect that. So what we're going to draw though is we're going to have to do the values for tangent. So at tangent we do negative pi halves is less than bx, which is 4x here, is less than pi halves. And then in order to solve this, in general we would want to divide by 4, or maybe easier to think about it since I'm dealing with fractions as multiplying by 1/4. So if I have on the left hand side 1/4 times negative pi halves, that's negative pi eighths. In the middle I have x, of course, and on the right hand side I have pi eighths. So my period is actually pi fourths because I go from negative pi eighths to positive pi eighths. 2 pi eighths would be pi fourths. But my graph needs that information that I just figured, which means that I would go from negative pi eighths to pi eighths. And then I'm going to need an additional period here in a minute anyway, so while I'm working on my asymptotes, I'm just going to figure out what that would be. So I already said that the full period is pi fourths, or 2 pi eighths. So if I took 2 pi eighths plus my pi eighths to get my next period, or my next asymptote, by moving a full length of my period to the right, I would have, let's see, what did I say, 3 pi eighths, right? Now, the first location for the halfway point's easy. Halfway between pi eighths and negative pi eighths is 0. Halfway between pi eighths and 3 pi eighths would be 2 pi eighths, and 2 pi eighths is the same thing as pi over 4. So that's my other x-intercept. And now then, since this is a graph of tangent, tangent is an increasing graph, whereas cotangent was decreasing, so my branches are each increasing. And notice I didn't do anything with the 1/2 in front. I did not do anything with that one. Alright, so this was tangent, cotangent. We have 2 more graphs that we haven't talked about, and that's secant and cosecant. Alright, so to do secant, what you have to remember or recall is you have to recall its reciprocal. So recall the graph of y equals cosine x. And then the x-intercepts of y equal cosine x become asymptotes of y equals secant x. Because if you've got an x-intercept, that means the y value is 0. Well, that means your output is 0, your cosine value is 0. If you try to take the reciprocal of 0, i.e. 0 over 1, it turns into 1 over 0, it's obviously undefined. And if you have something that's undefined, that's turning into an asymptote. And then our max points become minimums, and vice versa. Now, as you take any quizzes or any tests in this class on this graphs, you're going to need 2 colors. So let me just say that first. So the first thing you're going to do whenever you draw these graphs is you're going to, put it a little bit low, let's move it up a little bit more, is you're going to draw the graph of cosine. Okay, so that's where we're going to start. We're going to start by drawing the graph of cosine. As you'll recall, cosine goes out to 2 pi, and here's pi in the middle. And then you have pi halves and 3 pi halves. And then over here on the left-hand side, you have the same values. You have negative 2 pi, negative 3 pi halves, negative pi, and negative pi halves. And the graph of cosine goes up to 1 and down to negative 1, right? Alright, so let's sketch the curve of cosine in here. I'm going to sketch it in this blue color that I'm working in, I think. Cosine has a peak at 1, and then it hits the x-axis down to minimum, back to the x-axis, and then to the maximum. On the left-hand side, to the x-axis to a minimum, back to the x-axis, and then to a maximum, and then we'll connect the curve. Very nice. Okay, so like I said, the x-axis, or the x-intercepts, become asymptotes. So that's what we're doing. And I'm drafting them in yellow. This is my alternate color that I need. So everything in yellow is going to be my graph of cosecant. I'm sorry, of secant. And then each of my maximums become minimums, and my minimums become maximums. And I draw sort of these U-shaped branches that are in fact the graph of secant. So I need to make sure when I'm doing this that, because I've got two graphs on this equation, that I label which one's which. So this one right here in yellow is y equals secant of x, and the graph that was in blue was y equals cosine of x. But here's the deal, every time you draw secant, you're going to draw cosine, so you need two colors. Pencil for the first one, and some other color, marker or colored pencils, or just a colored pen. Black's not good because black looks too much like the pencil you're already using. So blue pen, green pens, purples, pinks, I don't care, something else, okay? You can even use red because I don't even grade in red, so it doesn't matter. Alright, so the next one is cosecant, and cosecant is very similar to secant, but you use its reciprocal. So you're going to recall the graph of y equals sine x, because that is the reciprocal of cosecant. The x-intercepts of y equals sine x become asymptotes for y equals cosecant x. And just like before, the max points become minimum points, and vice versa. So the first thing we're going to do is we're going to draw the graph of sine. Okay, so just like when we dealt with the one before, I'm going to draw them in blue. So we have we have pi halves. Doesn't look good. Let's try that again. There we go. Pi halves, pi, 3 pi halves, and 2 pi. In the other directions, we have negative pi halves, negative pi, negative 3 pi halves, negative 2 pi. We go up to 1 and down to negative 1. And our graph of sine actually starts at the x-axis. So we've got this point. Goes up to maximum, back to the x-axis, down to minimum, back to the x-axis. On the other side, instead of going up first, we'll go down to the minimum, up to the x-axis, up to the maximum, and then back down to the x-axis, and we'll connect our curve. And of course it looks very nice. Alright, then, like last time, we're going to use yellow and we're going to create my asymptotes. So all my x-intercepts become asymptotes. Including, in this case, the y-axis. That's fine. It's another good reason for having a different color is you can write those asymptotes on top of those graphs. Alright, and then peaks become valleys of these U-shaped branches, and the valleys become peaks. So we have these U-shaped branches all the way. Kind of look like a sort of a trapped parabola. Parabolas are not actually trapped, but these sort of have that same shape or feel to them. Alright, so guidelines for graphing. If we want to graph y equals a cosecant bx or a secant bx, again b greater than 0, and of course if it's not, we've talked about what you do. You first graph the corresponding reciprocal function. So if you have a cosecant bx, you're going to first graph a sine bx. If you have a secant bx, you're first going to graph a cosine bx. You're going to use sketch your vertical asymptotes from the guide curves, equations, x-intercepts in a different color. That's what we used our yellow for. And then you're to sketch the U-shaped branches above and below the guide curve. Let's say typo there, curve, in a different color. Those are our basic guidelines here. Alright, so we're going to do 2 examples, I believe, of this very thing. So the first thing we've got to do is to recognize that this equation is not the first one I'm going to graph. I'm first going to graph the reciprocal equation, which will be y equals 2 sine of 1/2 x. Now when we graphed sine functions, the first kind of things we did is we talked about what is the amplitude and what is the period. And we're going to start there again as well. What is my amplitude? Well, it's 2. What is my period? Well, it's typically 2 pi divided by, and then we divide by the b value, which is 1/2 here. So if we simplify this, this becomes actually 4 pi. And we're going to draw an axis then that goes out in both directions for sine, out to 4 pi and negative 4 pi. Oops, let's try that again. So here's 4 pi, half that is 2 pi, half them again. This is really nice because it's at pi, 1 pi, or yeah, let's just say pi, and 3 pi. And if I go the other direction, 1, 2, 3, and 4 have the same value. They've got negative pi, negative 2 pi, negative 3 pi, and negative 4 pi. I go up to 1 and down to negative 1. And I'm going to plot my sine curve. My sine curve starts at the origin, up to maximum, back to the x-axis, down to a minimum, and then back to a maximum. On the left-hand side, we go to a minimum first, x-axis, maximum, x-axis. And my guide curve in blue looks like this. And this is the graph I need to label it, is y equals, okay, I'm running out of space there, let me give myself a little bit more. Y equals 2 sine 1/2 x. Then we're going to take yellow, and I'm just going to continue to use those same colors. We're going to use yellow, and we're going to mark out the asymptotes in yellow based on the x-axis intercepts, or the x-intercepts. And mine are not looking all that lovely and straight today, so forgive me for that, but imagine that they were. And then we take our peaks, they become valleys for our U-shaped branches, and our valleys become peaks. And then my graph in yellow, and my lacking space above, so I'll write below, my graph in yellow is y equals 2 cosecant 1/2 x. And I'm feeling like maybe when I did the graph before I failed to write those down, so let's double check. Yes, of course I did for cosecant. So in yellow over here, this was y equals cosecant x, and in blue it was y equals sine x. I do want you to show which one's which based on the colors that you're using to draw them. Alright, back to where we were. So this was the graph of 2 cosecant 1/2 x. We have one more, and it's graph of secant. You notice the difference in this one is that we've got a vertical shift going on, which does in fact change things a little bit up. So let's write our graph reciprocal first. So this will be cosine. Right, that didn't work very well. Let's try again. Cosine 2 pi thirds plus 2. So a couple features. First is that my amplitude is 1. My period is, well, let's see, it would be 2 pi divided by 2 pi thirds. And very quickly I'm going to find out that if I simplify that, I get 3, which is kind of an awkward period length, but we'll deal with that too. And then my vertical shift is up to. So I need to remember that. And if you'll remember, when we graphed secant or sines and cosine curves, we actually dealt with the shift up first, and we will do that here as well. Whoops, trying to do something different, and that didn't work. Okay, so first thing we're going to do is we're going to tell what the shift up is going to be. So let me use we'll use orange. So the first thing I want to do is I want to mark out, oops, that I've got to shift this up to. So I've got a new sort of line of symmetry in the middle, or a new middle, x-axis sort of. And I need that to go in both directions, of course. And my graph is not quite far enough out there, so let's make it just a little bit bigger on the edges. Let's come over here. Oops. Let's use that same color, orange. Okay. All right, now I'm supposed to have a, we'll do this in blue for the cosine graph. It's supposed to go out to 3. Half of 3 is 3 halves, and half of 3 halves is 3/4. Now we need the halfway point between 3 halves and 3. Well, how do you do that? Well, you take 3 halves and you add 3 to it, so 3 halves, and if I turn 3 into halves, it would be 6 halves, which would be 9 halves total. And if I take 9 halves and divide by 2, that's 9/4. Right? Because anytime we divide a half by something by 2, we get fourths. So that's 9/4. On the left-hand side, of course, you have the same values. So I have negative 3/4, negative 3 halves, negative 9/4, and negative 9 halves on the left. Now, because this is a graph of cosine, I will start at a peak. Now you might notice that I already laid out my up to business, but I also had an amplitude of 1, which means we would go up and down 1 from my new dotted line. Well, up 1 would be at 3, and down 1 would be at 1. And this is a cosine curve, and cosine curves start at maximum. So I'm going to start up here at the top. We're going to hit the new dotted x-axis, so to speak, go down to a minimum, back up to the dotted line, and then back to a maximum. And then over on the left-hand side, down to the x-axis, or the dotted line, minimum, back to the dotted line, and then back to maximum. And we're going to connect this curve. Okay, I'm not doing a very good job connecting my dots today. You'll do much better, I'm sure. And then this curve in blue is y equals secant of 2 pi thirds plus 2. We're going to take our yellow, and our yellow is actually going to take the graph's new x-intercepts. That is to say, it's the places where we're actually crossing my dotted line now instead. And I know that doesn't exactly follow the guidelines I gave you for graphing, but if you look back at the guidelines I gave you for graphing, they didn't say what to do if you had a vertical shift. They were not dealing with any vertical shifts at all. So when you have a vertical shift, your asymptotes are not the x-intercepts, which is a good thing, because if you realize there are no x-intercepts on this graph, the blue graph. But there are intercepts for where it intercepts this vertical or this horizontal shifted line. So we're going to take this graph and this line that has been shifted up, let me say it that way. We're going to then do the same thing we did before. We're going to take our peaks and turn them into our valleys. Okay, that didn't work out well. Let's try that one more time. That's better. And then our valleys will turn into peaks for our U-shaped branches. And that would be our graph, which we will then write in yellow. Y equals, oh, I made a mistake before, didn't I? I'll fix it. This is secant 2 pi thirds plus 2. This should have said previously cosine right here, right? So let's fix that. That was the graph of cosine in blue, not secant. The graph of secant is in yellow. And then we're done.